When we investigate space, we gaze straight toward our own starting point. We are offspring of the stars. Brian Cox realizes that before the enormous detonation, there was something horrendous. It is hard for conventional individuals to envision the monstrosity of the condition that led to all that we know today: stars, the Milky Way, millions of other galaxies, and ultimately, ourselves. The prestigious astrophysicist attempts to explain this unimaginable state of the universe before its birth in a straightforward way, and his answer can even explain who we are, where we come from, and what we are made of. These inquiries have been driving people since they were able to think. We are standing here on our little globe, which, compared to the newly known size of the universe, is not even a speck of dust. And we are trying to understand what everything means. We look billions of light years into space with telescopes, and instead of answers, more and more questions arise. It almost seems as though the universe is trying to escape our research, or as though it is constantly answering our questions, and we are just not able to see those answers. Brian Cox shares the view that our universe is still a great mystery. However, the English scientist is also certain that the universe is definitely explorable and that it's not too difficult to uncover the secrets of this seemingly limitless space, if we look closely. Was there really light in the beginning? A statement from Brian Cox: light is the only connection to the universe. Have you ever wondered if the Bible and science share anything in common? Both seek to explain how the world was made, what rules apply in it, and who we are. The Bible states that in the beginning there was God, and He created the world from nothing in 7 days. In the Christian God's world, there was quickly light, bright and shining. But science questions this. If we trust the currently accepted standard model of cosmology, there was no light at all in the universe for millions of years. For this reason alone, scientists long believed that we humans would never be able to see the beginning of the universe. The reason for this is simple: we can only see light. Our telescopes filter light traces that have been traveling for billions of years and collect them into images. Where there is no light, our telescopes cannot see anything, and we can't explore it. If the Big Bang occurred in darkness, and it was dark for ages afterward, we would never be able to see this epoch. However, the James Webb Space Telescope has shown us something different. This marvel of technology looks back an incredible 13.6 billion light-years in time for us, and it thus moves very close to the edge of the Big Bang, which is thought to have occurred around 13.8 billion years ago. Now comes the first surprise. Webb shouldn't technically be able to see anything from that epoch 13.6 billion years ago. This epoch was supposedly the Dark Age. There was no light, and thus nothing for us to observe. Yet Webb's images show us rows and rows of bright and beautiful galaxies. So there was indeed matter, and it was already incredibly well developed at that time. So far, there is no trace of a dark age, and we have to ask ourselves if our science is really correct when it claims that the universe came from nothing and then was dark for a long time. Was light and matter there sooner than we thought? And is the Bible somehow right when it claims that light was present quickly, or even from the beginning? To understand this, we first need to see what light actually is. Before the Big Bang, there was light. A statement from Richard Feynman: if quantum mechanics has not shocked you to the core, you have not understood it. The great mathematician Albert Einstein was the first to describe the nature of light. He believed that light consists of individual photons, each of which collides with electrons, exciting them, and thus producing visible light through electromagnetic waves. Light is therefore created as a kind of energy through rotation, friction, or collisions. Now we need to realize that these processes happen at all known subatomic levels. Quanta and even smaller particles change, which means they appear and disappear again. They interact slightly with each other, or they are connected to dimensions that we have not yet understood or explored. All of these processes are movements and dynamics that create waves and radiation. If rotations, frictions, and collisions also occur here, a type of radiation, and therefore a form of light, will also emerge. Only, these light waves move outside our normal ability to see them. Richard Feynman was one of the first quantum physicists to understand the true extent of this science. Quanta are the basis of all matter, not the Big Bang or large-scale phenomena such as stars or planets. Everything is made of tiny particles that fluctuate and emit light. These particles are uncanny, or even shocking, because they behave completely irrationally. Quanta only form fixed states when they are observed, otherwise, they remain in a state that we could describe as unformed potential until they are committed. They can be either, and the truly frightening thing is that they theoretically hold this status even while they form a fixed structure. A quantum that becomes the building block for a table and forms this solid structure as long as we observe it also holds the potential to be a chair, a tiger, or a drop of water. What does this tell us about the beginning of our universe and? Simple to answer, our universe is conceivably one potential reality shaped into its as-of-now noticeable shape and structure. Yet, at the same time, it is likewise endless other things, or possibly contains the potential for some things. Brian Cox, before the universe, there could never have been nothing. A statement from Brian Cox, the objective of particle physics is to explain to us what lies under the surface of everything and the way things are connected, me, you, the Earth, the Sun, and 100 billion more suns. The magic of our science is that it's not as objective as we sometimes suppose. If we recall physics class or other parts of science, many of us have good or even bad memories of numbers, data, and facts in our minds. However, real science, and even physics, are far more daring than memorizing formulas and numbers. Essentially, scientists don't really know that much about the true mysteries of the universe. As Brian Cox says, our main connection with the universe is light, but there is more to the universe than light, and we don't even begin to see light. Particle physics has its own way of uncovering the mystery of the universe and, additionally, of our reality. The basics are simple. You take a particle and then split it into its parts until it can't be split any further. The theory sounds good, but the practice is challenging since, up to this point, all well-known particles can be broken down into even smaller particles. Imagine a particle is a city, then a quantum might be an orange that lies somewhere on a table in this city. And we know even smaller particles, which would then be just a few crumbs inside this city or the dust that is collected somewhere on a table. We can't even really see particles, and even our best scientists can't see the other particles. We just know that they are there because we can observe their effect. Regardless of how far and deep scientists have investigated these aspects, they have not found the basis of creation. It's still unclear today what matter truly consists of and how it is formed. Matter is said to have begun at the start of the Big Bang. At first, there were only free particles, and everything was too hot and swirling to allow for solid connections between the particles. Then it cooled off, and the first chains of particles eventually formed atoms and, finally, matter, or so the theory says, at least. The Big Bang must have been preceded by Einstein's nothing, at least, that's what the theory of relativity implies. However, physicists have now discovered that nothing cannot theoretically exist. But how did they reach this conclusion? In quantum physics, it was shown that a particle can never be completely destroyed or obliterated. The information that formed the particle always remains present. Therefore, nothing could have existed before the Big Bang. Essentially, the information that later formed the universe must have been present. Now, of course, we can ask further questions, such as, where did this information come from? Quantum scientists explain this with a quantum fluctuation, which, in plain language, means that an infinite carpet of particles existed. The particles emerged, killed each other, and then vanished again, since no force or thing that we know or can name appeared inside this neutral fluctuation. This nothingness didn't consume any space either, and no time passed. Nonetheless, the nothingness was everything, and much more. Inside the fluctuation, not only the potential for our universe, as it is, existed but also for countless other universes or things, spaces, and dimensions that we can't imagine. The idea that there were countless other variations of what we now know as the universe is overwhelming. Imagine a universe in which everything is pink, where matter flows instead of being solid, where only thoughts exist, or where time runs backward. These are just 4 variations of sextillions or countless more. But why did our universe emerge? And why did we humans emerge, who don't even understand how the universe works? These questions can push us to the brink of our minds, and perhaps we need to go beyond these limits to comprehend the true nature and variety of our universe. Subscribe now and don't miss any new video.